welcome to The Explainer. You ever wonder what's really going on inside those giant windowless buildings that seem to power our entire digital world? Well, today we're going to pull back the curtain on the invisible orchestra of specialized hardware inside a data center. All the routers, switches, and firewalls that make pretty much everything you do online actually possible.
So here's our game plan. We're going to tackle this in 5 logical chunks. We'll start with the absolute basics, how data even gets from point A to point B. Then we'll see how we protect it, how we manage it when there's a ton of it, where we store it, and finally, how we connect to all of it without a single wire in sight.
And this right here, this is the core mission. Just keep this in mind as we go. No single device is an island here. It's really a massive, high-speed team effort to get information where it needs to go, both securely and efficiently.
Okay, let's dive right into our first section. We're talking about the 2 most fundamental devices you will find in any network, big or small, the router and the switch. These 2 are truly the bedrock of all data movement. So think of a router as kind of like the grand central station for data. It's not really concerned with, say, the specific devices in one little office. Its job is to connect entirely different networks together, whether those networks are in the same building or on opposite sides of the planet.
So how do they do it? Well, routers use IP addresses. You can think of these as the zip codes of the internet to make all their decisions. Their whole job is to find the best possible path to get a piece of data from your local network, your LAN, to a wide area network, or a WAN, somewhere else in the world. And what's really interesting is that sometimes this zip code intelligence gets combined with the raw speed of a switch, creating this powerful hybrid device we call a Layer 3 switch.
All right, so if a router connects different networks, a switch is the device that connects all the computers, printers, and servers within a single network. The switch creates the local neighborhood, and the router connects that neighborhood to the rest of the world. Now, what makes switches so special is just the raw speed. See, unlike routers that are thinking about the big picture zip code, switches operate at a much more local level, using hardware addresses called MAC addresses. They use these specialized computer chips called ASICs to move data at just incredible speeds inside the local network. And here's a cool little trick. A lot of them can actually send electricity right through the network cable itself, that's power over Ethernet, to power things like security cameras or office phones. Pretty neat.
Okay, so our data's moving. Now let's talk about how we protect all of it from outside threats. Because when you have information flying around at lightning speed, security is, without a doubt, absolutely paramount. And this comparison just perfectly shows the evolution of the firewall. See, old school firewalls were like a security guard who only cared about which door number you were using. But modern, next generation firewalls, they're way smarter. They can actually look at the traffic and understand if you're browsing a website or streaming a video or using a specific business app, and then make much more intelligent security decisions based on that. But today's firewalls are real multitaskers. They're usually the main gateway to the internet, so they also end up handling routing, creating secure encrypted tunnels using VPNs, and managing how private internal addresses get translated to public internet addresses. They're basically the Swiss Army knife of network security.
Now, beyond firewalls, we have these 2 specialists. Both of them are on the lookout for known attacks and vulnerabilities, but it's what they do about it that's different. An IDS is like a silent alarm system. It sees a problem and it tells the authorities. An IPS, on the other hand, is like a security guard that not only sees the problem, but actively steps in and blocks the attack before it can even get inside.
Okay, so our data is moving and it's secure. But what happens when you have a massively popular website with millions and millions of users? Well, you need devices specifically to manage that fire hose of data for peak efficiency and to make sure the site stays online. This is the secret sauce behind how huge websites stay online. To you, it just looks like you're visiting one website. But behind the curtain, a load balancer is acting like a traffic director, intelligently spreading all those incoming requests across a whole fleet of servers so that no single one gets overwhelmed. It's also smart enough to detect if a server fails and reroute traffic on the fly. And they do way more than just balance traffic. They can take on heavy tasks like encryption and decryption, freeing up the web servers. They can cache frequently requested stuff to deliver it faster, and even prioritize certain kinds of traffic over others, making the whole experience faster and smoother for everyone. Next up is the proxy server. The best way to think about a proxy is like a personal shopper for all your web requests. So instead of your computer going out to the internet directly, it just asks the proxy to go get the information for it. The proxy goes out,
fetches the data, and then delivers it back to you. Now, this middleman position is incredibly powerful because it's the perfect spot to enforce security rules. A proxy can cache popular websites to speed things up for everyone, it can demand a username and password before anyone gets internet access, and it can scan all the incoming data for malware. It's basically a protective buffer between your users and the Wild West of the internet.
Right, so all this data, it has to live somewhere. So now let's talk about the specialized systems that data centers use to store and access just absolutely massive amounts of information. And this is a really, really crucial difference. With a NAS, a network-attached storage device, if you need to change just one sentence in a huge document, you have to download the entire file, make the change, and then upload the entire file back. A SAN, or a storage area network, is way more efficient. It gives you what's called block-level access, which is like being able to edit that one sentence directly on the library shelf without ever having to check out the whole book. Now, because these storage systems are constantly reading and writing enormous amounts of data for tons of different applications all at once, they just can't share the regular network. They get their own dedicated high-speed superhighway to make sure that all that storage traffic doesn't create a massive traffic jam for everybody else. And finally, let's talk about how we untether ourselves from the wall and connect to all this infrastructure wirelessly. Because, let me tell you, enterprise-grade Wi-Fi is a very different beast from what you've got running at home.
That device you see on the ceiling in an office or at a university, that's a purpose-built access point, or AP. It's not a router, it's not a switch, its one and only job is to be a bridge, translating the 802.11 wireless signal from your laptop into the 802.3 wired Ethernet signal that's on the main network. That's it.
Okay, now imagine you've got a campus with hundreds, maybe even thousands of these APs. Trying to manage them one by one would be an absolute nightmare. And that's where the Wireless LAN Controller, or WLC, comes in. This thing is the brain of the entire wireless operation.
This controller is what network admins call a single pane of glass. From one central place, an administrator can deploy new APs, monitor the health of the entire wireless network, push out critical security updates to every single AP at the same time, and generate reports on performance. It's really the only way to manage a large-scale wireless network efficiently.
So, can you see it now? The invisible orchestra conducting your digital life. From the router that connects continents, to the switch connecting your desk, the firewall standing guard at the gate, and the load balancer managing the crowds. Each device plays its own specialized, vital part. They all work together in this silent, high-speed harmony to create the fast, secure, and reliable connections that all of us depend on every single day.